Hello and welcome to today's lesson looking at convex lenses. So in today's lesson we're going to look at how to draw ray diagrams for convex lenses. So if we're successful and we learn in today's lesson, we can describe what convex lenses are used for. We can understand and describe the different images formed by convex lenses, and we can be able to draw ray diagrams for convex lenses, which falls into the following part of the GCSE Separate Science Physics specification in the Waves topic 4.6.2.5 lenses, which as mentioned before is separate science only content. So mirrors are pieces of glass that reflect light or any ray, whilst lenses are pieces of glass that refract light rays. So the light will change direction as it's transmitted through that particular lens, and we can show how the light is refracted with a lens diagram. Now in a lens diagram, our eye is placed on the right hand side of the glass and the object is placed on the left hand side, as shown here. Now to draw accurate lens diagrams, you've got to follow some fundamental rules. There's an imaginary line that passes through the center of the lens, which we call an optical axis or principal axis. Now the object in our ray diagram is the thing that gives off the light, whilst the thing we see as humans is the image. Now we can draw an object or an image in a lens diagram by using an arrow, where the arrowhead references the top of the object slash image and the tail of the arrow represents the bottom of the object or image. Now where lines cross in a lens diagram, an image is formed. So we can show that here in this particular example. So you can see the lens in the middle of your screen. You can then see the optical axis going through the lens, through the center of the lens. The object is placed on the left hand side and the human eye is placed on the right hand side. Now there are two different types of lenses. There are convex lenses, which are lenses which brings the rays together or converges them at a focus. So convex lenses are converging lenses. Now convex lenses can produce either real or virtual images, but they make parallel rays converge at the principal focus, whilst concave lenses are lenses that spread the rays out or diverge the rays. So another name for concave lenses are divergent lenses. Now a concave lens can only produce virtual images. So concave lenses make rays appear to come from the principal focus of the lens. Now we can symbolize the lenses on ray diagrams with the following symbols. So your convex lens, which is your converging lens, and your concave lens, which is your diverging lens, are represented with the two symbols. Now an example of a convex lens is the lens in your phone or the lens in your eye, because they're always bringing light together to a focus, to a point. Now this is an example of a concave lens which always spreads light away. So an example of a concave lens could be the lens in your glasses or a lens in a telescope. Now concave lenses are indented towards the center. They look like a cave, which is where the name concave lenses come from. Now today's lesson we're going to focus on convex lenses, which links into GCSE biology, as your eye lens is a convex lens. Now just to clarify, in practice light is refracted at the both surfaces of a lens, where the light hits the front surface of the lens and then leaves the back surface of the lens, but for simplicity's sake we'll only draw one effective refraction as if it happened at the center of the lens. Now obviously this isn't the case, but it's a simplification. Now if we assume that the light ray hitting a lens has come from very far away, infinity, such as the sun, we get the following diagram. Now for objects very close to us we can't assume this, but we can assume this for objects very far away. Now this is because if the light has travelled a long distance, the light rays have become parallel to each other. So this can only happen with a convex lens. So what happens is if the light becomes parallel to each other and they hit the convex or converging lens, the convex lens makes the rays converge to one point, the principal focus or the focal point. Now the distance from the center of the lens to the focal point is called the focal length. So just to clarify, if we assume the light comes from a very distant source, we say the lines are parallel to each other. Now when this takes place, the point in which the light will then converge in a convex lens from this infinity is called the principal focus or the focal point. Now it's important to note that the distance from the center of the lens to the principal focus is called the focal point. Now for ray diagrams, you need to be able to describe your images formed, and they come in 3 different categories. So your image formed can either be upright or inverted. Upright means the image is in the same orientation as the object. Inverted means the image is the different or opposite orientation to the object. Magnified, which means the image is bigger than the object, or it can be diminished. The image is smaller than the object. And the image can be real, so the image can be projected onto a screen. The lines cross on the diagram, or they can be virtual. The image cannot be projected on a screen. The lines actually don't cross on your ray diagram. Now you can calculate the equation for magnification with an equation given to you on your equation sheet. So we know that magnification is the image height divided by the object height. Now this will be calculated by literally measuring the image you have and the object you have on your sheet of paper in front of you. Now you are given this equation on your equation sheet, so you're not expected to memorize this equation, and it's the same equation found in GCSE biology when you are looking at microscopes. Now it's important to note that magnification has no units, it is just a ratio. Now this means a magnification greater than 1 means the image is bigger than the object. A magnification less than 1 means the object is bigger than the image. Now the image height and the object height can be in any height units, millimeters, centimeters, meters, kilometers, as long as they are the same for both the image and the object. So it's an important idea to note. Now to understand what image is formed by the lens and how you can describe it as either real or virtual, magnified or diminished, or upright or inverted, you've got to draw a ray diagram for a lens. So to understand the physics of a lens and an object with a lens, you must have to apply the rules of the lens diagram. So to draw ray diagrams, you carry out the following step. So you draw in your lens as a vertical straight line in the center of the paper. You then draw the optical axis as a horizontal straight line going perpendicularly through the center of the lens. Now remember your convex lens symbol for your ray diagrams, and note in most examples the optical axis will already be drawn in for you in your examination question. You will then draw in the principal focus as F on the optical axis. Now remember it's the same on both sides of a lens because the lens is symmetrical, so the optical axis will go through the lens at the center, and the principal focus will be the same point on either side. Now in most examples this will be done for you in your examination. Now the focal length is the length from the center of the lens to the principal focus or focal point. Now again, for all lenses it's assumed the focal length is symmetrical on either side of the lens. Now, you then draw in the object giving off the light as an arrow, and you'll be told where to draw this in your examination, or you'll be given this in your examination already. Now remember, the arrowhead represents the top of the object and the tail represents the bottom of the object, as such like that. Now it's very important to note this idea. Now the first step you will carry out is you draw a straight line from the top of the object to the lens. Now you always draw this with a sharp pencil and a ruler, and you'll always draw an arrow on your ray. So this is one light ray coming from the top of the object. Okay, so it would look something like this. Now it's very important to note that what happens is that the light will refract through the principal focus. So you draw it in as such like this. Now this occurs because, as we showed before, parallel rays always refract through the focal point of a lens. So as this straight line is parallel with the optical axis, as we looked at before, it will refract through the focal point of the lens, which comes from the definition of the focal point. So it will look like this. You will then draw a second line from the top of the object through the center of the lens. So it would look like this. Now again, it's important to note that this line goes through undeflected, so you keep drawing straight on. It will continue on its path without changing direction, so it looks something like that. Now it's important to note this because rays traveling through the center of a lens do not refract. That's because the light ray, if it's traveling through the dead center, all hits the lens at the same time, so it won't have that refraction or bending effect. Now, it's important to note that where the two lines meet is where the image forms. Now remember, you drew your two lines from the top of the object, so where the lines cross must also be the top of the object. So the lines are crossing here, so therefore the image must be formed here. But remember, it's the top of the object, so you can draw in your image as shown here, but the point where they cross is in fact the top of the object. So it would look something like this. Okay, now you can describe what your image would look like. So this image is real, it's inverted, and it's magnified. Now you know it's real as the two lines are actually crossing in the diagram. You know it's inverted because the image and the object are different orientations. In layman's speak, the image is upside down. And it's magnified because the image height is larger than the object height. Now, as an insurance, you can draw a straight line from the top of the object through the focus on the left hand side of the lens. This doesn't need to be carried out, but sometimes people like to do this to make sure that they've drawn their diagram correctly. So what happens is, if you draw your diagram correctly, if when you draw your straight line through your principal focus on the left hand side of the lens, once it then hits the lens, it will travel in a straight flat line across. So in theory, all 3 points will cross at the same point, so you know you've got your image correct. So these are the rules you must follow to draw your convex lens diagram correctly. So you draw your lens in as shown here with your focal length in maybe twice your focal length drawn symmetrically on both sides on your optical axis. You would then draw your object in as an arrowhead. You would then draw a ray parallel to the axis from the top of the object, and it's refracted through the focal point on the other side as shown here. Because remember, if there's a parallel line hitting a convex lens, it will refract through the focal point of the lens. Your second step, you'll draw a ray to the center of the lens from the top, and it passes through undeflected, because if it's passing through the dead center, all of the ray hits the lens at the same time, so it doesn't actually refract and change direction. And then the third step is where the lines cross. That is where the top of the object forms, and so as a result you can use this to work out where your image forms from your lens as shown here. So, a lens forms an image by refracting light. In a convex lens, parallel rays of light are brought to a focus at the principal focus, and the distance from the lens to the principal focus is called the focal length. Now, ray diagrams are used to show the formation of images by convex and concave lenses. Now, the image produced by a convex lens can be either real or virtual, and the image produced by a concave lens is always virtual. Now, you should be able to construct ray diagrams to show the similarities and differences between convex and concave lenses. The magnification produced by a lens can be calculated by the equation magnification is equal to image height over object height. Now, magnification is a ratio and has no units, and the image height and object height can be measured in either centimeters or millimeters. Now, in ray diagrams, a convex lens is represented by the following symbol, and a concave lens is represented by that following symbol. So if we've been successful and we've learned in today's lesson, we can describe what convex lenses are used for, we can understand and describe the different images formed by convex lenses, and we can draw ray diagrams for convex lenses. I hope you've enjoyed today's lesson where we've looked at convex lenses in the GCSE separate science topic of waves. Thank you very much and have a lovely day.